How do touchscreens work? Touchscreens are now a common form of input device. They allow simple touch to launch an application or to carry out many of the functions of pointing devices, such as a mouse. The main use of touchscreens is in mobile phones and tablets, and sometimes in laptops and computers that have touchscreen functions. There are three major types of technology applied to touchscreens. These are capacitive, infrared, and resistive. In capacitive touchscreens, they are made out of many layers of glass act like a capacitor, creating electrical fields between the glass plates in layers. When the top glass layer is touched, the electrical current changes and the coordinates where the screen was touched is determined by an onboard microprocessor. A few devices that use capacitive touchscreens are smartphones, certain laptops, and computers. They are convenient and more durable than resistive touchscreens. You are also more likely to have your bare fingers be available for use if you're walking around and using your device. Although it may be liable to breaking, the screen is durable enough that it can survive at least a few drops, and it is quite easy to use. It is also fairly cheap to manufacture, and as such, most mobile devices such as Android and Apple use these. Only one side of the insulator is coated with a conductive layer. As it has no moving parts, it is moderately durable but has limited resolution. It is also prone to false signals, only allows the use of bare fingers as a form of input, and it needs calibration. It is therefore most often used in simple applications. For example, your phone. It is also used in industrial controls, your tablets, and kiosks, rather than places that require complex technology such as hospitals. It is also a medium cost and has good screen visibility, even in sunlight. The next type is infrared. There are two types, heat sensitive and optical. In heat sensitive screens, they use glass as a screen material and need a warm object, such as fingers, to carry out an input operation. In optical screens, it also uses glass, but instead uses an array of sensors in the form of a grid. The point of contact is based on which grid coordinate is touched and disrupts the photons emitted. Infrared touchscreens are newer than the other two, and thus lens manufacturers will have infrared touchscreens as an option. However, they are much more durable than capacitive touchscreens, and they don't require patterning on the layers. Even the strongest capacitive touchscreens are still liable to breaking. Both systems allow multi-touch capabilities, have good screen durability, and require major impacts to break the glass. The optical system allows the use of bare fingers, glove fingers, or a stylus for input, whereas the heat-sensitive system only allows bare fingers. Along with that, it's relatively expensive in comparison with capacitive touchscreens. Finally, in resistive touchscreens, they make use of an upper layer of polyester and a bottom layer of glass. When the top polyester layer is touched, the top layer and bottom layer complete a circuit. Signals are then sent out by a microprocessor, and the calculations determine the coordinates of where the screen was touched. It is relatively inexpensive technology, works in the rain, and bare fingers, glove fingers, or stylus can be used to carry out an input operation. However, the screen visibility is not as great as the other two, being poor in strong or direct sunlight, and does not permit multi-touch capability. The screen durability is also only fair. It is vulnerable to scratches, and the screen wears out through time and through being bended by contact.